ChatGPT, more people are talking about, kids are cheating on their homework. Well, maybe we need to rethink homework if we for now and forever, we're going to have machines that can write. We all see all the exciting things that this technology can do, but it hasn't happened yet in most industries.
In an ever-changing world that's all about staying connected, building connections, and seeing where the next collaboration takes a marketing campaign. From an initial brief to the follow-through, what paths are going to make a campaign success more than a possibility? Hi, I'm Brett Marchand, CEO of Plus Company. This is Partners in Possibility. At this moment in time, we sit in a striking phase in the development of AI. We have witnessed its potential, but have not yet seen its widespread impact. Our guest today, Avi Goldfarb, calls this phase between times. Avi is the Rotman Chair in Artificial Intelligence and Healthcare at the University of Toronto and Chief Data Scientist at the Creative Destruction Lab. A renowned expert on the digital economy, he has testified before the US Senate and co-authored the best-selling book, Prediction Machines, The Simple Economics of Artificial Intelligence, and its follow-up, Power and Prediction, The Disruptive Economics of Artificial Intelligence. Today, in part one of our conversation, Avi and I talk about how Canada has led the world in AI development, some of the trade-offs between privacy and innovation, and what it means to be living in the between times. I thought maybe one of the places we would start, just because of your background, is your work and how you've track the evolution of digital marketing, and maybe touch a little bit on how this industry compares to other industries.
So I was a graduate student. I was studying economics. It's my PhD in the late 1990s. And I was looking for an industry to study because that's one of the things we do. And there was this new industry called the internet that no one knew anything about. And I figured that if I studied something that no one knew anything about, no matter what I discovered, it would be new. And so, as a graduate student, I said, okay, well, let's try to get our heads around a little bit of the economics of what's going on in the internet. And I settled in. I worked with a startup at the time that was out of Cary, North Carolina, and worked with what we would now think of as the early stages of big data. And looked at the choices that consumers were making as they surfed the web. Mm. And the key insights there were, at the time in the late 90s, the advertising-supported internet looked a lot like the magazine industry in terms of how, what people did and how they behaved, and also in terms of how the advertising worked. And then the focus over time became on search engine competition, way back at a time when there was genuine search engine competition. So I had 18 search engines in my data set. We called them internet portals in the late 90s. Google was in the data, but they were the 17th most popular search engine in the data set.
Wow.
And so the world has changed a lot.
Yes.
The ad industry has changed a lot, and the advertising supported internet has transformed partly through AI, through what we might think of as prediction technology and targeting, so that it doesn't look so much like the old magazine industry anymore.
Yeah, it's interesting because I think a lot of people think AI has only really been with us since ChatGPT came along, but in fact, it's been around for a long time, particularly in digital media.
Absolutely. Key to this transformation of advertising that we've had over the past 25 years has been the ability to understand the user, to use data to predict what the user might need and when they need it in order to get the right ad to the right user at the right time. And underlying that prediction in many, many cases is machine learning technology, which is the core technology underlying today's AI.
And interestingly enough, I mean, you ended up at U of T, and I don't know if this is a coincidence or because I know you're from Toronto, but next door to you was the godfather of AI, right? Geoffrey Hinton. So
I'd love to say it was planned, but it was completely serendipitous, but it turned out to be wonderful. So I arrived at the University of Toronto in 2002. And for the first decade of my career, my focus was understanding the economic impact of the internet on inequality, on market outcomes, and especially on the advertising and the rise of the ad tech industry.
Mm-hmm.
The advertising industry, so just measuring the impact of online ads, understanding the implications for privacy, et cetera. Then in 2012, at the Rotman School, we started this program called the Creative Destruction Lab, which was a program that helped science-based startups scale. The program is still going strong. We're now in 13 universities around the world and have hundreds of startups coming through. But in our very first tiny cohort back in 2012, there was this company, Atomwise, run by a PhD student out of Hinton's lab in our comp sci department that was using artificial intelligence to discover new pharmaceuticals, to discover new drugs. And put yourself back 11 years ago, that just seemed crazy.
Yeah.
The idea that you could use artificial intelligence technology to discover new molecules and cure disease, that was way beyond the scope of anything I'd heard of at the time. And but it turned out he was onto something. We dug in and we understood when he said it was artificial intelligence, what he meant was a branch of machine learning. And machine learning is prediction technology. It's computational statistics. So using information you have to generate information you don't have. He said, okay, wow, this is really interesting. They were one of 25 companies in our cohort, one of sort of 7 to 10 that really succeeded that year. Okay, move on to the next year. The next year, we had 2 more startups also using AI. And by 2015, we had this flood of AI startups in our lab to the point where we added a whole nother cohort focused on AI. That at the time, as far as we know, we had the most AI startups of any incubator in the world. And at that point, my co-authors and I said, hey, this is something we need to get our heads around. And so we changed our career focus from being about understanding the economic impact of the internet and how it affected industry, and in my case, the marketing industry in particular, to thinking more about this new technology, AI. So it came out of our comp sci department. We saw it through the lab. Honestly, if I was a normal professor and not running that lab, I think what would have happened is I would have opened the school newspaper and said, hey, isn't it wonderful? Great things are happening in our comp sci department. And that would have been it. But this combination, because we were helping these startups scale and we saw the startups in our lab, that's what led to this change in my research agenda to really try to get my head around this technology.
And I don't think people around the world really understand how long and how much money had been going against AI, particularly in Canada, because when it was being abandoned in most universities in the world, the Canadian government leaned into AI 30 years ago, I guess. And obviously what's happened at U of T with Jeffrey Hinton and all the great work that's come out of that, but also University of Montreal, University of Alberta. I mean, most people don't realize that this was really the center of AI for a long, long time.
In the 70s and 80s, the core AI technology was something called expert systems, which you can think of as a whole bunch of if-then statements to try to have the computer do what an expert would do. So you'd have researchers following doctors as they did all sorts of stuff, and then try to say, okay, well, if with a bunch of if-then statements, let's try to imitate the doctor. It turns out the world is really complex, and those systems broadly failed. And so that led to what we call the AI winter, where around the world investment in AI dried up.
That's right, an AI winter. Due to the ineffectiveness of those early expert systems all around the world, people got off the AI train, except in Canada. And that choice put Toronto at the forefront of AI for the next several decades, until the rest of the world caught up.
In Canada, the Canadian government decided, through luck or strategy is an open question, to invest in this alternative AI technology, which was, instead of trying to figure out exactly what an expert did, what you do is you use statistics. You use this tool called machine learning to make a good guess, effectively, to predict what the right decision is or what might happen in a given situation. That technology was co-developed, largely at the University of Toronto through Professor Hinton's work, then later at, also at the University of Montreal, a parallel technology called reinforcement learning that is a real complement to the deep learning technology invented here in Toronto, was invented in Alberta with Rich Sutton. And together, Canada had this huge lead. Now, in the 1990s, the lead that Canada had was irrelevant to the world because everyone else had said this technology doesn't work and they'd given up.
Yeah.
But we invested and got better and better to a point where it actually, even as of 2010, seemed like a massive waste of effort. Then in 2012, a team of doctoral students working with Hinton won what's called the ImageNet competition. So a competition to label pictures. And they didn't just win, they blew the competition away. Their technology was just clearly much, much better than anything else out there. And it was at that moment that the research community and sort of the venture capital community started paying attention to what was happening here in Toronto and to some extent to Montreal and Alberta. And then by 2015, the tech world knew we had something, and it was really exciting.
Somewhere in that journey for you, you also got involved in privacy, right? Because I know that you gave expert testimony to the Senate in the U.S., et cetera. How do you end up in front of the Senate?
I'll make that a short story. It's a long story, but I'll make it a short story. So I was studying online advertising, and the key advance in online advertising relative to how advertising worked in the 90s and earlier was this rise of targeting technology. So we could use data to figure out which users might want what and when. What does targeting technology require? It requires, as I said, data. And so our work on that said, hey, you know what? This data is really useful. And if there's restrictions on who's allowed to use what data, that might affect the ability of our advertisements to work. And so Catherine Tucker and I put together a research paper that said, hey, Europe has stricter privacy regulations than the US. This is before GDPR. This is some regulations that came into practice in 2004, 2005. Let's see how that affected European advertising relative to American advertising. Mm-hmm. It's just as a research question, hey, if you restrict data flows, if you add privacy regulation, does that affect advertising outcomes? And we found that it had a massive effect, a negative effect on how ads worked. So in the sense that American ads over the course of that decade got slightly better in terms of their effectiveness under a few different measures, and European ads got much, much worse. And largely it seemed to be driven by this regulatory change. That paper led to some attention and said, hey, we can measure the costs of regulating privacy, not just the benefits. That led to two different ideas that we explored. The first was, okay, that's the cost side. What about the benefits? Like, there must be good things about privacy too. And can we start trying to understand and measure what consumers get out of privacy? And we did some work on that in the sense that when we target ads using data in ways that make it clear that the advertiser has an intent to manipulate the user, users don't like that.
Yeah, makes sense.
And then, no one likes being manipulated. That's sort of, we all know that. And then the other side of it was that first paper showed that there's this trade-off between privacy and innovation because the innovation in advertising slowed down the European regulation. We had another paper that showed a trade-off between privacy and competition, that these privacy regulations seem to lead to market power for dominant tech firms. The communication of those trade-offs to say, hey, yes, privacy is really good, and here's reasons why privacy is good, but it's not free, and here are the costs. That's what led to my testimony at the U.S. Senate Committee of the Judiciary.
And some people say that some of those privacy regulations in Europe actually put them back significantly when it comes to, digital advertising, et cetera. And I mean, let's be honest, right? Where if you look at where all of the economic rent has come from in this industry, Google, Meta, Microsoft, and then some in China, as we know, very little of it's come out of Europe. Do you think that was part of the reason?
I do think that was part of the reason. There's some excellent research that pretty carefully documents a few things. One, the regulation, especially GDPR, to some extent the earlier regulation, but especially GDPR, hurt the advertising supported software industry in Europe. So less venture capital investment in that industry, fewer new entrants, even outside of venture capital, and challenges in the existing companies to grow, the smaller European ones. And at the same time, there's evidence that shows that GDPR seemed to lead to an increased role of Google in Europe, even relative to the US.
You've given some great history on this. When we're talking about AI in 2023, what do we mean? Like, how's it evolved?
When we read about AI in the media, and you hear these petitions, we should stop AI, the essence of those stories is something we see in science fiction, right? That we are on the cusp of the Terminator, these machines that can do everything we can do, and they won't listen to us, and it's going to take over the world and destroy us.
Yep.
Or maybe more optimistically, we're on the cusp of the Jetsons, which are machines that can do everything that we can do, but they do listen to us. Those visions, I don't think those visions are crazy, but that's not the technology we have today or in the very near foreseeable future. What we have today is very, very good computational statistics. It's prediction technology. Right. It takes data, the information you have, and then it fills in missing information. Mm-hmm. And those first applications of machine prediction about a decade ago commercially were good old-fashioned prediction problems. Like you walk into a bank and you want a loan, and the loan officer has to predict whether you're going to pay them back. But as the prediction technology has gotten better, we've started to realize there's new applications of machine prediction. It's still machine prediction, using data you have to generate data you don't have that we didn't think of before. So at first, things like medical diagnosis, that's what your doctor's doing. They're taking in data about your symptoms. They're filling in the missing information to the cause of those symptoms. That's still prediction. Recommending what somebody might want, recommendation engines, that kind of thing. And it turns out in the last year, we figured out that not just identifying the label for an image, but creating an image can be solved with prediction. And writing a paragraph or an essay, short essay in response to a query is also a prediction. What ChatGPT is doing is it's predicting the set of words that is the best response to a particular query. If you ask it for something that's similar to what's in its training data in the documents that it's read before, it's going to give you a useful response. And it's going to be grammatically correct. And it's going to be able to do things that many of us find really hard, like instantly create rhymes, okay? Because it has a database and that's of rhymes, and it can match what a rhyme might be. Once you recognize its prediction, it's not a sentient being, you'll understand its strengths and weaknesses.
We're going to take a quick break. When we come back, we'll talk about the similarity between what's happening today and what happened in the 40 years following Thomas Edison's patent of the light bulb. Welcome back to Partners in Possibility. I'm Brett Marchand. We're living during a phase that Avi Goldfarb calls between times. We've discovered and witnessed the potential of AI, but we haven't yet seen its widespread adoption and effects. And you use this great analogy about how electricity, even though I think the patent was in 1879 for the light bulb by Thomas Edison, how it didn't really have an impact on industry and the business until much later.
The 1880s were an incredibly innovative time in electricity. Mm-hmm. That was the electric light bulb. Tesla's patent for the alternating current electric motor was in 1890. Anybody who was paying attention in the 1880s could tell that this technology, electricity, was going to transform the way we lived and the way we worked.
Sounds very familiar.
It sounds very familiar. But it wasn't until the 1920s. It was another 40 years till half of American households and half of American factories were electrified. Right. So it took 40 years until this technology that was clearly transformative affected most of us at home and at work. Mm. And so that disconnect is the underlying challenge. What happened was in the 1880s, it was clear that, for example, an electric motor was really powerful. Mm. But what did factory owners do They took a steam engine, dropped it in the electric motor at the exact same point, and left the workflow the same. And if you leave the workflow the same, your upside is limited to however much you end up saving on energy costs. And you don't save that much in energy costs. You might save 5, 10, 15%, but not much more than that. And so for the vast majority of factory owners, it wasn't worth the effort of taking out their steam engine, dropping the electric motor, figuring out how to get electricity distributed into the factory through wires, laying out the wires throughout the factory in a way that was, fire safe and effective. It wasn't worth all that investment to just do what you always did a little bit better.
Right.
And so even by 1900, less than 5% of factories were electrified.
And along comes Henry Ford.
And some others, and they realized that electricity isn't just cheap power, right? Electricity allows you to do things differently. And so in the 1890s, the factory would have been organized around the steam engine. The most power-hungry machines would have been as close as possible to the steam engine because, I don't know if you remember your high school physics, but energy dissipates with distance. And so you want to make sure your power-hungry machines are close to your steam engine, to your power source. And that meant you didn't move things around your factory that much. You had pretty skilled artisans doing a lot of the work, and each person did a lot of different steps in the production process. Electricity came along, and Henry Ford and these others realized we can now distribute our machines around our factory. And so what you might think of as the quintessential 20th century factory with inputs in one end and outputs out the other, with modular production, that is a direct result of the change that electricity enabled. That's when we see a change in the trajectory of adoption and sort of rapid adoption over the next decade or two.
Right.
With AI, it feels like we're in the 1890s, right? Mm-hmm. We all see all the exciting things that this technology can do, but it hasn't happened yet in most industries.
Right.
And a lot of the applications we're imagining are, let's do what we always did, but a little bit better.
Mm-hmm.
And that lack of imagination is natural. Like that's of course where we would be, but it means that we haven't figured out what the organization of the future looks like. And that's what we mean by this concept of the between times. We can see the future, but it hasn't happened yet. ChatGPT, more people are talking about, kids are cheating on their homework. Then, well, maybe we need to rethink homework if we for now and forever, we're going to have machines that can write.
Right.
And so those challenges are fundamental, and they need to be overcome, and they are being overcome, but it's not straightforward because we have to be much more ambitious with what we're trying to do with technology.
Right, because people are looking at AI as how do I save 15 or 20% of my legal costs because contracts can be done more effectively and many other applications. But you're right. I'm not sure anyone's really thinking about it and how it can fundamentally change a business and create an evolution, a revolution, right? Because the Industrial Revolution came out of the modern factory. And what kind of opportunities do you see in front of us as far as industries go or businesses go in using AI to be more transformative, as you say?
Okay, I see them everywhere. So what's already been transformed by AI? Maybe we'll start there. There's two industries that have already seen some transformation. One is the taxi industry. And so if you look at the first applications of GPS systems to help predict how to get from point A to point B, of digital maps with navigational predictions, were, hey, let's look at professional drivers, like truck drivers and taxi drivers, and make them drive 5% more efficient. Mm-hmm. They're the ones who are going to get the most benefit because they spend most time driving. Right? And that happened. So like 2008 to 2012, a lot of the application and a lot of the benefit for these technology for GPS systems was for professional drivers. Mm-hmm. Then Uber and Lyft and others realized that's crazy, right? This technology combined with digital dispatch means that anybody can be as good as a professional driver. So what do we need to limit the number of people who can professionally drive to these people who have licenses and all these other steps? And that change in that personal transportation industry is a direct result of digital navigation, so navigational predictions, and a handful of other tools that led to a transformation. The other industry, of course, is the advertising industry. I don't need to tell you, but advertising in the 1990s and earlier was not a data-intensive industry. Okay,
That's right.
There was a lot of gut feel, and a lot of intuition. We had some demographics, but it wasn't that, okay, we want to know exactly, here is a individual user. We want to know what they want at that moment, and we're going to serve an ad for them based on their needs. And then along came targeting technology. Along came transformation and data and some machine learning tools. And the industry went from these rate cards in magazines and even on Yahoo and elsewhere to real-time auctions based on these predictions to price ads and lead to an entirely new ad tech industry. That is a direct result of what's happened with prediction technology.
Thank you for listening to Partners in Possibility. That was part one of my conversation with Avi Goldfarb. Next week, we'll continue our conversation about AI and prediction technology, the vital role that human judgment plays in maximizing the efficiency of the technology, and how it will change our industry forever. We'll also talk about how we at Plus Company are working to connect various touch points while continuously measuring creative performance to grow business with our newest innovation, AOS. Stay tuned.